Hello, and welcome to this introductory video of the ATS200S High Performance Flame Photometer. We're going to demonstrate today the simplicity and ease of use of this instrument, as well as the basic safety features that it has. As you can see, it's got a touchpad, a window, a covered chimney, furnace, and a door to protect the inside internal organs of the instrument. During use, the door is usually left open, and you have access to the gas control and safety of the air control as well. The safety features include safety all round, so that the only hot area of the instrument is above. Therefore, no one can by accident burn themselves, had the burner be on the side. And we also have electronic cut-offs if the flame is not visible, if the air is no longer being supplied, or if the gas itself also runs out. Simple operation is just all you need to do is turn on the on-off switch from the rear of the instrument, like this, and automatically the air will be supplied to the instrument, as you can hear. And with the supply, the gas will also be introduced into the instrument, and you'll see here it's requesting whether I need to start the flame. I say OK, and it will automatically start the flame. Using the viewing port, we can identify that the flame is actually lit, and it asks us, do we need to optimize the flame? We are fine. You control the fine control using the internal fine control knob here. It's actually perfect as it is. Usually the warm-up time for this instrument is around half an hour, but varies on, obviously, location of the instrument. So now we're on the standby screen. OK is the start menu, so we press OK. And this is our main menu. For this demonstration video, we will just be concerned with a new analysis to see what the procedure is and the simplicity of saving the data and not needing to transcribe data as well. So up is a new analysis. Here we set the ranges. Different instruments come with different programs. This is set for 0 to 200. For our example, we'll be measuring in a range of 0 to 10 for 4 elements: sodium, potassium, lithium, and calcium. So this is within the range that it's requesting. So we will then go ahead and press OK here to save and exit. Now we're going to start to calibrate the instrument. Set high cal value. We press OK. Here, this is actually for the program. It comes with a default program of 30 ppm, and we will change these values to what we require by pressing the down keys. So this is for sodium, high cal value. Right, we move to potassium. Lithium. And calcium. Right, here we go. Now we're going to use the different units that we have available. We're going to be using ppm, parts per million. Optimized flame, the flame seems fine, it's still operational, so we don't need to optimize. Now we set down arrow for the analysis. And start analysis is OK, or we're going to actually calibrate the instrument first, since it's our initial analysis. Calibration may be needed alternately depending on the amount of samples you'll be running and on the quality of the water and samples that you introduce into the system. So we're going to calibrate the instrument now, and this instrument comes with various programs. Program 1 is the full 4 elements. Program 2 is a single element. analysis. Program 3 is sodium and potassium. So we'll go back to program 1 and use this to analyze all 4 elements simultaneously at the same time. Offsets, this is to reset the electronic offsets, which we always do. So we'll allow the instrument to reset its offsets. But they may change with the, if the instrument has not been warmed up long enough, you would need to recalibrate those. That's why we have a warm-up period of 30 minutes prior. Locale start calibration. So we now introduce distilled water into the system. We wait about 10 seconds just for the initial induction of the first sample of the locale. Okay. Now we press OK. So here we have the initial reading, and they're all zeros. Okay, now we go for high cal. High cal, we continuously look at the flame in order to see when the actual sample has been introduced into the flame itself. It typically takes about 6 seconds. Here it took maybe 3 seconds. I can see that the flame has changed color, and so we're ready to press the high cal calibration. This is a 10 ppm sample of all the 4 elements. As you see, the readout is at 10, so we are happy with this. So now we can start the analysis. Therefore we return to distilled water. And OK to start analysis. So this is now sample 1, which is distilled. We'll give it about 10 seconds before we continue. We'll go again to sample 2. So this is maybe 10 seconds after the actual introduction of the sample, and we're getting zeros. It indicates how quickly this instrument will go back down to 0 after it has taken this high cal reading. We'll now analyze for 5 ppm, which is within the range that we have calibrated the instrument for. Here we go. So I'm now looking at the flame. It has now changed color, and now I can go ahead and make the next reading. We're coming up with the first set of readings, and we can press this up to 20 times and take 20 readings in one go. This is the 5th reading, and so forth. Once we're done, we can then push up to print analysis or save the analysis on the actual instrument itself. We will print the analysis to have a hard copy. As you can see here, the printer is now printing, and it has information of who's done the analysis and what program was used, the time, date, and this is all therefore saved as a hard copy and can be then transcribed into a computer for final and kept on record as a hard copy. And that basically completes our introduction to this equipment. We thank you for watching, and have you any further questions, you can contact us through our website at ats-technology.com. All the best.